Intelligent control can generally be classified into three types of control modes based on servomotor control patterns: open-loop control, semi-closed loop control, and closed-loop control. Hello, everyone. Welcome to the mini-lecture on intelligent equipment fault diagnosis and maintenance. Today, we will explore the principles of intelligent open-loop control technology. In our daily lives, many devices and systems utilize the principle of open-loop control. So, what exactly is open-loop control? Let's discover it together. In this lesson, we will focus on several key points of intelligent open-loop control technology. 1. Overview of open-loop control. 2. Working principle of open-loop control systems. 3. Characteristics of open-loop control systems. 4. Disadvantages of open-loop control systems. 1. Overview of open-loop control. Open-loop control systems are commonly encountered in everyday life. For example, the water dispenser supply system operates according to a preset pattern when we press the dispense button, without considering whether the user has taken away the cup or if the cup is already full. This is an example of open-loop control. Now let's understand what open-loop control is. An open-loop control system, simply put, refers to a control method where the output of the control system is not affected by feedback signals and depends only on the input signal for control. It does not form a closed-loop feedback circuit, hence it is called open-loop control. Common examples of open-loop control systems include TV remote controls, car accelerator controls, toasters, and parking indicator systems. 2. Working principle of open-loop control systems. Next, let's delve into the working principle of open-loop control systems. The working principle of open-loop control systems is relatively simple. It directly calculates the output signal based on the input signal and then executes the corresponding action. During this process, the system does not adjust the input signal according to changes in the output signal, meaning there is no feedback loop. Please take a look at this picture. This is a typical open-loop control system. The control device receives an input from the input device, performs logical operations to obtain an output, which is then applied to the controlled object. Under the influence of external disturbances, the controlled object undergoes stable adjustments before driving the actuator. 3. Characteristics of open-loop control systems. Its characteristic is that the controlling device directs the actions of the actuator to change the working state of the controlled object, and the controlled variable correspondingly changes. However, this change does not become the reason for the controlling device to act again. That is, there is no feedback loop between the control signal and the controlled variable. Next, let's learn about the characteristics of open-loop control systems. 1. Simple structure. The design of open-loop control systems is relatively simple and does not require complex feedback loops and sensors. This makes open-loop control more straightforward and economical in hardware implementation. 2. Low cost. Due to the simple structure, the manufacturing and maintenance costs of open-loop control systems are usually lower. This is an important advantage for applications with strict cost control requirements. 3. Fast response speed. Since there is no feedback link, the response speed of open-loop control systems is usually faster. Changes in the input signal can quickly lead to changes in the output signal, which is very beneficial for applications requiring rapid response. 4. High reliability. Open-loop control systems do not rely on feedback signals, so they have higher robustness to faults or interference in the feedback loop. In some harsh working environments, open-loop control may be more reliable. 5. Easy to implement. Open-loop control does not require complex algorithms and computing processes, so it is easier to implement on platforms such as embedded systems and microcontrollers. 6. Strong applicability. In certain specific situations, such as simple mechanical motion control and timing tasks, open-loop control can meet basic control needs without introducing complex closed-loop control mechanisms. While open-loop control systems have some distinct advantages, they also possess notable disadvantages. Let's examine the disadvantages of open-loop control systems. 1. Limited precision. Open-loop control lacks feedback mechanisms, so it cannot adjust the input signal based on changes in the output signal, which limits the system's precision. In practical applications, due to various factors, the output signal often deviates from the desired signal, and open-loop control cannot correct these deviations. 2. Weak anti-interference ability. Due to the lack of a feedback link, open-loop control has weaker resistance to external interference. Once the system is disturbed, the output signal is easily affected, leading to a decrease in control effectiveness. 3. Poor stability. The stability of open-loop control systems is usually poorer. It is unable to adjust the input signal in real time to compensate for changes in system parameters or external disturbances, so the system is easily affected by unstable factors, leading to fluctuations in the output signal or deviations from the expected value. 4. Error accumulation. In open-loop control systems, errors may accumulate continuously during the control process. Since it is unable to adjust the input signal based on the output signal, errors cannot be corrected in a timely manner, resulting in a reduction in control precision. We have learned about the principle of open-loop control in this lesson. We can now weigh the decision to use open-loop control based on specific application needs and control requirements. In scenarios that demand high precision and stability, it may be necessary to consider using closed-loop control or other more advanced control methods. This concludes today's lesson. I hope that after class, you will review and consolidate your understanding, complete the following exercises, and prepare for the next lesson. See you in the next class.